Alright, what's up guys? I'm back with another video, and in today's video we're going to find the equivalent resistance of this circuit, and this is also another Y delta transformation example. Right, so we're going to try and solve this. Now if you guys haven't watched the first video of Y delta transformation, please go and watch that so you kind of have a basic understanding. Right, so this is example number 2. So as you can see here, from here we have to find the resistance seen between A and B, right? So in between A and B over here. And then you can see here, it looks kind of difficult. This circuit kind of looks tricky. I don't really know where to start. I don't really know what to do. That's kind of what I get. But it's actually very simple if we just redraw the circuit, right? And let's see how we're going to do that. Well, we have a circuit over here. We have a diamond shape, right? And we have a little rectangle on the left side. Well, what we can do is actually bring this 5 kilo resistor, and kind of put it in the middle, right? So think of it like this. Think of it as this circuit as in a 3D model, right? And we can rotate this rectangular piece around. So essentially we can rotate this rectangular piece around so for it to come down the middle over here, and we can rotate the A around and the B around over here. So I know it looks a little confusing, so let's go ahead and redraw it, right? So this is what stays the same. We have our diamond, we have our 1K over here, our 3K over here, 4K over here, and our 2K over here, right? So we have 1K, 2K, 4K, and our 3K, right? So now what I'm trying to say is that we can rotate this A around, right? So this A, let's put it over here. So essentially what I'm saying is that if we have an A over here, this is the same thing as if we have an A going outward, right? Because this A is still connected to the same node, right? So we can just erase this A in the middle, and essentially what we get is this, right? So we can just bring this A around. We can do the same thing for the B. So essentially we can have the B outwards like this, right? So this is what we have. But what happens to the 5 kilo ohm resistor on the left side, right? Well, essentially that 5 kilo ohm resistor, it has 2 points, right? So it connects to these two nodes, this node at the bottom and this node at the top, and we're saying that there's a 5K resistor in between these two nodes, right, that connects, right? But essentially we can just write down that the 5K resistor can be in between these two nodes this way. So we can have a 5K resistor over here, right? Because all we have is a 5K resistor. The only rules we have to follow is that this 5K resistor, oops, sorry, that got a bit messy real quick. So all we have so far is that this 5K resistor is in between this node. So let's call this node X, and let's call this node Y. We know that 5K is in between X and Y, but we can also write down the 5K in between X and Y this way, right? And have the 5K over here instead. So essentially we can erase all of this on everything on the left side, and essentially we get a new circuit that looks like this. Now, from looking at the first example, what can this circuit kind of look like to you, right? If you can kind of determine, if you guys can take a couple minutes to yourself and try to figure it out for yourselves, kind of examine it, and we can get back to the video. Now, for those of you who have stayed, the circuit is a Y delta, because as you guys can remember, right, we can circle this whole right side or the left side, right? Let's do the left side. If we're looking at node A, we can circle the whole left side, and essentially we get a triangle where it's A over here, the node A, right? We get 1K over here, we get 3K over here, and we get 5K down the middle, right? So we get 5K, 3K, and 1K. And essentially we get another Y delta transformation, right? So we can then use this, and then we can have a Y delta transformation and transform this left side into A on the top, comes down vertically as 5K, right? Then on the left side we have 3K, and on the right side we have 1K. Right? And essentially we get our Y delta transformation that we want to get. And that will make the circuit much more easier to solve, as it will be similar to example 1, right? And if you guys don't understand what I kind of talked about, please go back and watch example number 1 as you'll get a better understanding. But let's go ahead and go watch this full problem. Let's go ahead and solve this full problem. So let's go ahead and solve this full problem right now. Okay? So we know this is what's going to look like. So we know how to find what R1, R2, and R3 are equal to. So let's label this R3. This is R1, and this is R2, and we know our rules, so let's go ahead and solve that. Well, R3 we know is equal to 3 times 1, right? 3 times 1 divided by 3 plus 1 plus 5. And what is that equal to? That is equal to 3 over 3 plus 5 is 8, and 1 is 9, so 3 over 9, right? And we know that in decimal form this is equal to 0.33. Well, what about R2? Well, what is R2 equal to? Well, we know that R2 is equal to 1 times 5, right? Because we're going to multiply these two numbers, 1 times 5, R2 times R3. So it's going to be 1 times 5 divided by 1 plus 3 plus 5, which is equal to 5 over 9. And what is that equal to? 0.45, right? Then we're going to do R3. Well, what is R3 equal to? R1 equal to? Well, R1 is equal to 3 times 5 divided by 3 plus 5 plus 1, right? Because R1 times R3, right? So R1 is equal to 3 times 5 over 1 plus 3 plus 5, which is the sum of all the resistors. So essentially we get 15 over 9, which is equal to 1.6 kiloohms, right? So then these are the ones that we get. We get 0.33 kiloohms, and we get 0.45 kiloohms, and we get 1.6 kiloohms, right? So that's what R3, R2, R1 become, and essentially we can draw a new Y delta, right? So we know that R3 on the top, so we start with A. We have A over here. We know that coming down, we get 0.33, and then we know that R1 on the left side becomes 1.6, and we know that R2 on the right side becomes 0.45, right? And then that is our new Y delta. So now let's incorporate this Y delta into the circuit above so we can solve the total equivalent resistance of the circuit. So if we're examining the circuit on the right and we have our Y delta essentially on the A on the left side, right? We have coming down, we have 0.33, and then on the left side, right? So if we look at the bottom side, essentially we get 1.6, and up top we get 0.45, right? So we have this on the left side, right? Now we see on this side we have a 2 kiloohm and a 4 kiloohm also attached to it, right? So we know that if we have this, because we get rid of this middle part, we kind of erase this whole 5K in the middle, right? Because we got rid of it because of our Y delta, essentially this all becomes in series. So we can attach it to the 2K on the top, and we can attach it to the 4K on the bottom, right? So then we can add these two up, 0.45 plus 2 and 1.6 plus 4, as those two are in series, but they're not all in series because we can't forget that there's another node over here that attaches number B, right? So we have this circuit, what it looks like. So essentially what we get is we get A on the left side, right? We get 0.33 kiloohms, right? And then on the top, let's see what we get. We get 0.45 plus 2, which is 2.45. And on the bottom, what we get is 1.6 plus 4, which is just 5.6, right? And then these two are attached to node B, right? Essentially, that's what our circuit looks like. Well, how do we solve this? Well, this is very simple because we know that 2.45, right? We know that 2.45 and 5.6 are in series with one another. So because we're in series with one another, we know how to solve that. So we know that to find the equivalent resistance, it's equal to 2.45 multiplied by 5.6 divided by 2.45 plus 5.6. And let's see what we get. We get 1.70 kiloohms. So our final REQ for this one is 1.70 kiloohms, but now we have to finish it for the last step, right? So we have A over here still connected to 0.333 kiloohms. And then this becomes a straight line, and it's in series with 1.7 kiloohms. And then we have B on the right side. So the resistance between A and B is just the sum of these two resistances, right? So 0.33 plus 1.7. So we get 0.33 plus 1.7 kiloohms, which is equal to 2.03 kiloohms, right? So our R equivalent between A and B is equal to 2.03 kiloohms, and that's our final answer. So that's how we solve this circuit using Y delta transformation, right? I hope you guys enjoyed and understood the video. If you guys did, please make sure to like, comment, share, and subscribe. If you guys have any questions or concerns, please comment down below. And if you guys want me to cover any more specific topics or questions that you guys might have, please comment down below, and I'll make sure to make a video on it as soon as possible. All right, thanks for watching, guys.